6.3 notes. Proving a quadrilateral is a parallelogram. For this warm-up, we're asked to find the coordinates of the midpoint of segment AC and segment BD. Then answer the question, what is the relationship between segment AC and segment BD? Alright, well, let's start with the midpoint formula. If you look to the top right of your screen, you'll see the midpoint formula. Remember, it's x1 plus x2 over 2, comma, y1 plus y2 over 2. So I'm going to take the coordinates of segment AC, so I'm going to take the coordinates of point A and point C to find the midpoint of segment AC, and the same with segment BD. When I do that, I discover that they have the same midpoint. The midpoint for both is 2, 1.5. So what does this tell me about the relationship between AC and BD? Well, if they have the same midpoint, that means they cut each other in half, or they bisect each other. Next question, how did the slopes of segment AD and BC compare? So if I look, and if I were to draw a segment between points A, D, and then between points B and C, I can just count the slope. To get from point A to point D is up 1, right 3. To get from point B to point C is the same, up 1, right 3. So how do their slopes compare? They're the same. All right, same slopes. Remember, that means that the segments are parallel. So AD and BC are parallel. Next question, what about the other pair of opposite sides, AB and DC? If we were to draw segments between those 2 points for each, would those be parallel? Well, AB, that's a vertical segment. DC, that's also a vertical segment. So yes, vertical segments are parallel. So if we were to draw those segments in and go from point A, D, C, B, and draw sides around this quadrilateral, what type of quadrilateral would it be? It's a parallelogram, for a couple reasons. The 2 pairs of opposite sides that we found using the slope formula, and diagonals that bisect each other using the midpoint formula. Let's review the properties that we already know for parallelograms. Both pairs of opposite sides are parallel and congruent. Both pairs of opposite angles are congruent. An angle and both its consecutive angles are supplementary. And last, diagonals of a parallelogram bisect each other. So let's look at this first example. It says for what value of y is, and it's not A, B, C, D, it's P, Q, R, S. So that's a typo, sorry. For what value of y is P, Q, R, S a parallelogram? Well, since I only have sides, I know that opposite sides either need to be parallel, or I need to be able to prove that opposite sides are congruent. And since I'm given some algebraic expressions on side lengths, I'm going to go ahead and prove that opposite sides are congruent. I have to start with segment PQ and segment SR. Since they both have x as their expression for length, I'm going to set up this equation. 3x minus 5 equals 2x plus 1. So I'm going to solve for x by taking 2x away from both sides. I get x minus 5 equals 1. Last step, add 5 to both sides, and I'm left with x equals 6. So now that I know the value of x, I can go back in and solve for y. I know that segment PS and QR would also be congruent if PQRS is a parallelogram. So I'm going to set x plus 2 equal to y. I know my value for x. It's 6. I'm going to substitute that in, and I get y equals 8. Here's an example with angles. It says use the diagram at the right. For what values of x and y must EFGH be a parallelogram? Well, there's a couple things I know about the angles of parallelograms. Opposite angles are congruent, and any angle and its consecutive angles are supplementary. So I'm going to see what I can use here to solve for x and y. If I look at that first property, opposite angles are congruent, all my opposite angles have different variables. For example, angle E is 3y minus 2. Angle G is 12x plus 7. One is a y, one is an x. Same with H and F. I have an x and a y. So if I were going to use this property, I'd have to set up a system of equations and solve it for both x and y. There's an easier way to do it. Look at angle E and angle H. They both have y. What do I know about angle E and angle H if this is a parallelogram? That they must be supplementary. So I'm going to set it up that way. I'm going to say that 3y minus 2 plus y plus 10 equals 180. And now I'm going to solve for y. So I combine like terms. I get 4y plus 8 equals 180. Subtract 8 from both sides. I get 4y equals 172. Divide both sides by 4, and now I've solved for y. Y equals 43. I can use this now to go solve for x. If I look at angle H and angle F, I could say that these are congruent. So I'm going to set it up that way. I'm going to say that 43 plus 10, because I substituted 43 in for y for angle H, equals 4x plus 13, that's the measure of angle F. So 53 equals 4x plus 13. Subtract 13 from both sides. 40 equals 4x. Divide both sides by 4, and you get x equals 10. Alright, so there's one more property in this section for a parallelogram, or one other way that we can prove that something is a parallelogram. And it says this: if one pair of opposite sides are both congruent and parallel, then the quadrilateral is a parallelogram. Well, here I have a picture of two skis. They're obviously the same length because they're the same ski. Imagine for a second that they're parallel, which they are. All right? Well, I can connect the tips and the tails of the ski, and now look, this is a parallelogram. Given that the skis are the same length and that they're parallel, we know that if we connected the tips and tails, those sides would also be parallel and congruent. Alright, so for this last slide, I want you to see if there's enough information to prove that each quadrilateral is a parallelogram. So try to remember all the different properties we've talked about for parallelograms. If you need to go back in the video to kind of freshen up on some of those, then go ahead. But at this point, I'd like you to pause the video and decide, is there enough information to prove that it's a parallelogram? If so, tell me how you know, and if not, just say no, there's not enough information. Pause the video now. Okay, let's go over the answers here. Number one, so this is going to use the property or the theorem 6-12 that we just talked about with the skis. All right, I know that segment AB and DC are both 5, so they're congruent. If I can prove them parallel, that's enough, right? One pair of opposite sides that are congruent and parallel is enough to prove a parallelogram. Well, angle A and angle D are supplementary. Therefore, we know that segment AB and segment DC are parallel using the converse of the same side interior angles property, right? If same side interior angles are supplementary, then lines are parallel. We know that. All right. So number one is yes. Number two is no. There's not enough information here. Number three is also no. Not enough information. Number four, we're going to prove that both sides are parallel. Both pairs of opposite sides are parallel. AN is parallel to LD because angle DLN is congruent to angle ANL. Those are alternate interior angles, so converse of alternate interior angles theorem. Same with the other pair of opposite sides. Angle ALN is congruent to angle DNL. That tells us that segment AL is parallel to segment DN. And if both pairs of opposite sides are parallel, then we have a parallelogram. Here's a review of all the different ways that we can prove a quadrilateral is a parallelogram. You can prove that both pairs of opposite sides are parallel, like we just did. You can prove that both pairs of opposite sides are congruent. You can prove that an angle is supplementary to both its consecutive angles. You could prove that both pairs of opposite angles are congruent. You could prove that diagonals bisect each other. And the new one we learned today, you can prove that one pair of opposite sides is congruent and parallel. Your homework for 6-3 is on mathexcelforschool.com, due Sunday at midnight.